Boom! Yes folks, Hume again. So as promised in the last video, we're going to just finish off what we started with this triangle. So just as we did in the case of the 30-degree reference angle, we will actually use some actual values in the case where the reference angle is 60 degrees. So in this case, let us say that we know that the cosine of 60 is 1 over 2, right? We know also that the cosine is the ratio of the adjacent side to the hypotenuse. So if the cosine of 60 is a half, 1 over 2, adjacent over hypotenuse, it means that the adjacent being 1 and the hypotenuse being 2, it means that the length of the hypotenuse is twice the length of the adjacent side. So if we make the length of the adjacent side equal to 1 and the length of the hypotenuse equal to 2, then using Pythagoras theorem, we could find the length of the remaining side AB. And again, I'm going to go through the stress of writing out the whole thing, even though you would have seen it in a preceding video. Good. The point of me doing this is that by recording it on a video, I don't have to do it repeatedly. I could just send people here and tell them watch the video. Alright, so we need to find the length of AB. So by Pythagoras theorem, we know that 2 squared, 2 of course being the hypotenuse, is equal to 1 squared. Well, sorry, opposite plus adjacent. I always like to put the opposite side first. Doesn't really matter at the end of the day, but you know, I have my little style now. I have a little style to the thing, right? Everybody have their own little style, and I want to encourage everybody to develop your own style. Don't feel that you have to do it exactly the way the teacher do it. Any teacher tell you that is doing you a slight disservice, right? Yes, sometimes you would want people to do certain things, right? But even within that context, what you will find a lot of times is that there's room for individual expression, and that is something that I like to encourage in my students. So I'm putting it out in the video now. If you want to put the adjacent side first, doesn't really make a difference. So h squared is equal to opposite squared AB, right? AB squared plus the adjacent squared, 1 squared. So 2 squared is 4 is equal to AB squared. This is AB all in brackets, right? Plus 1 squared is 1. So 4 minus 1 is equal to AB squared. So 3 is equal to AB squared. So AB is equal to the square root of 3, which is just that the square root of 3, which we know is equal to 1.73 to 2. So 3 significant figures, sorry. So the length of AB, having used Pythagoras theorem, we get that the length of AB is 1.73, whatever the units happen to be. So we're going to rub this off now. If you want to see it again, just rewind and you have it in front. So AB is 1.73. Good. So with these figures in mind, we could actually now calculate the exact values of the ratios, the trigonometric ratios for an angle, for a reference angle of 60 degrees. So we started with the sine. So the sine of 60 is equal to what? Opposite over hypotenuse, right? Opposite over hypotenuse, which is equal to 1.73 over 2, 1.73 over 2, which is equal to 0.866. Alright. The cosine of 60 is equal to adjacent over hypotenuse, which you already know is 1 over 2, which is equal to 0.5. And the tan of 60 is equal to the opposite over the adjacent, which is equal to 1.73 over 1 over 1, which is equal to just 1.73. Alright, so if you notice and if you remember from the previous video, you would remember that the sine of 30 was 0.5, which is also the cosine of 60. And you recall, of course, that the cosine of 30 was 0.866, which is the sine of 60. Now there is a particular relationship between the tan of 60 and the tan of 30. all right, but I'm not going to include that in this video, right? What we don't want to do is overcomplicate things depending on the basic level that we're speaking to. So when I'm speaking to my AdMaths students in my little AdMaths platform, then yeah, we're gonna go even further with this, right? So they will get the same videos up to this point, and then I hit on my next video where we talk about the relationship between tan theta and tan phi. But we're gonna leave that out for now. We're gonna stick with sine theta equal to cosine phi, and sine phi is equal to cosine theta. As a general math student, if you have that awareness, that's a big extra piece of the horizon, right? So if you're a math student and you're not doing AdMaths and you have this as part of your awareness, then you're in the game. Yeah? Of course, if you're doing AdMaths, if you're an AdMaths student, then this is pretty much expected to be par for the course, normal thing, right? Because it have more to this that we wouldn't try to cover in this particular video. So that is it. We would have spent about 2 or 3 videos discussing the 30, 60, 90 triangle. The next video after this one, we will talk about the 45, 45, 90 degrees. That is the right isosceles triangle that has its own special properties as well. And then after that, we do one simple example just to illustrate the use of Pythagoras theorem and trigonometry together in one problem. And after that, it's up to you. It's either you could do it on your own, it's either you could do it with help from somebody else, or you could do it with help and you want to come by me for the help, in which case the online platform is available for the rest of 2020 for the princely sum of $550 and its associated equivalents in other currencies across the region. Yeah, so that's basically it. So keep good, look out for the next video, plenty more to come.